Okay, so the seventh question in lead code is to reverse the integer. Okay, so the question here is we'll be given an integer, we'll have to reverse it. Okay, that is one thing, and it's a 32-bit sign integer actually, like it's a sign bit integer. So what we need to do here is we'll have to reverse it. Okay, and we'll have to print a result. Like we should still return the sign of it. Okay, and second thing is we need to check if this false intake, if this can be represented within a signed 32-bit integer. If it is not, if it overflows, right, we'll have to return a 0. So what does that mean is, so for example, initially what I thought is, let's say that if it is a 1 2 3, right, even though if I reverse it 3 to 1, it should also fall it should also, it should not overflow, right? Like in the initial assumption was this also has a 3 character and this also has a 3 character, how would it overflow, right? This was my initial thought, which is obviously wrong. So what does it mean is, let's say that I want to represent instead of 3 to 1, right? Let's say that I will give as 128. So to represent 128 we'll be needing what, 1 2 4 8 16 32 64, correct? We will be needing these many bits to represent. This is sufficient, right? 128 to represent 128, this will be enough. Okay, but now let's say that we'll reverse it, correct? Now what will happen, it will be 8 to 1, right? To represent 8 to 1 we will be needing additional bits, correct? So this is 128 and now 256 512, and also we will be needing 1024. We will be needing extra 3 more bits to represent this number. So in our case, what we are checking is if it exceeds 2 power 32, like I mean whatever the range is given, right? If it is exceeding, here it is exceeding, right? Whatever it was initially, our constraint was 128. It, after reversing, it went to 821. That doesn't fit in our range. So similarly we'll have to check, after reversing we'll have to check if it falls within our range, that is 2 power 31 minus 1. This is if it is less than or equal to this, and if it is greater than or equal to minus 2 power 31. Okay, this is what is the condition we'll have to check. That is one thing. While reversing we'll have to check with the overflow condition. And the next thing is, um see, like why are we like currently we are saying that it's a 32-bit integer, right? But why are we in the power it is 30 to 31? So to talk about that, let's say that if we have some 4 bits, let's say, right, i want I have this 4 bits, I want to represent a, let's say that I have a binary 6. So this will be 4, this will be 2, this will be 1, and we will talk about this later. Let's say if I want to represent a signed integer and also it is a 6, let's say I want to represent 6, 4 plus 2 6, and this will be 0. Okay, and this will be reserved to specify the sign here. Actually, if I want to say, if I want to specify positive integer, right, I will store 0 here. If I want to store, say it as a negative, it will be 1. Like there will be a concept called 2's complement all. Let's not go to that. So to represent 0, like this is like a reserved for to mention the sign. That's what it is about, signed integer. Okay, and now what is happening here is, so one bit is gone, right? We can use only this much, so that's why we get to see it, instead of 32 it is 31. Okay, and similarly here, right, here we have a 4 bit, correct? Initially, like it means that 2 power 4, 2 power, wait a minute. So like we have here 4 bits, right? Initially, like how much we can use here, basically, like if it is not a unsigned integer, right, we can store until 8, correct? But here how much we can store max to max is -1, right? That is what here is 2 power 3, 1 bit is gone, like I mean we cannot use it. And also how much we can store, that is -1, that is nothing but equal to 7, correct? Like I mean initially it was 4 bit, but 1 bit is gone now, that is to store an integer. So how much value we can store is now 2 power 3, correct? And also as we know, like I mean that will be actually -1, right? We cannot store 8 here, correct? We in this, using these 3 bits, only 7 can be stored. That will lead us to this formula, like 2 power 3 -1 is equal to 7. Similarly, in that range, in that positive range, it will be like 2 power 31 -1. This will be there, extra 1. Okay, so to conclude, so even though we have like let's say that 4 bits here, let's say that it's a 4-bit sign integer, right? 1 bit is gone now, so we'll have only 2 power 3. only we have 2 power 3 that we can store, and also we cannot store 2 power 3. This is an 8, right? We'll have to subtract it by 1. Similarly, we'll land into this. Okay, that is all about the range. And when it comes to the negative, there are things like 2's complement and all. That's why we don't get a minus 1 here. We'll get it only in the positive range. Okay, now coming to the implementation, right? So first thing is, this is the approach I have used. First, I have made sure that if it is a positive or negative, I'm checking if it is a negative or positive. Okay, and then I'm storing only positive value. Okay, I make sure that I've stored here, and I made it as a positive, and then it's a regular reversing algorithm, right? Will take a reminder and we'll append it to we will keep on appending to it, right? So that is it's all about. Once we reverse it, we'll then, if it was a negative, right, we'll multiply it by negative at the end, right? So there is no value loss. I mean, there is no, if it was negative, it will continue to be negative here. Okay, so now we got a final result after calculation, correct? Now the condition is we need to return this only if this falls under this range. If it is overflowing this range, right? If it is overflowing the 32-bit value, we should not. So this is the condition. If it is greater than this, or if it is less than this range, right, we should return 0. Else, if it is satisfies that condition, if it falls within this, then we can just return the reversed value. Yeah. So the submission rate was, it was comparatively it was 72% faster actually. Initially I was just converting to string and doing it, and it was like, I think it was only like 30 to 30% of it got submitted, but the thing is it was only good till only 30% actually. Yeah, thank you.